Our planet is a place of constant, mesmerizing change. We often see the world as a solid, permanent stage upon which the drama of life unfolds. Yet, the stage itself is alive, shaped by forces of unimaginable power and patience. The wind, the ice, and most profoundly, water are nature's great sculptors. They are the unseen hands that carve mountains, etch canyons deep into the earth, and mold the very coastlines that define our continents. This is the raw, untamable power of nature, a force that both creates and destroys, often in the same breathtaking moment. It is a reminder that we are but visitors on a world governed by ancient elemental rules. Look closely, and you can see the evidence of this power everywhere. A simple rainstorm, for instance, is more than just water falling from the sky. It is a force that dislodges soil, carries seeds to new ground, and feeds the great rivers that act as the arteries of our continents. Over millennia, this gentle, persistent action can wear down the mightiest of rock formations, turning stone into sand. Then there is the more dramatic display of nature's might, the crashing wave, the flash flood, the churning tempest. These events demonstrate, in a very immediate and humbling way, the sheer energy that water can unleash upon the landscape, reshaping it in a matter of hours. This constant shaping is a dance between creation and destruction. A powerful river flood may sweep away a forest along its banks, a seemingly catastrophic event. Yet, in its wake, it deposits a layer of rich, fertile silt, laying the groundwork for new life to spring forth, more vibrant than before. A storm-battered cliff may crumble into the sea, but this erosion provides the very sand that will form a new beach or a protective dune system miles down the coast. Nature does not operate with malice or intent. It simply follows the fundamental laws of physics in a cycle of renewal that has continued for billions of years, long before we were here to witness it. Understanding these forces is key to understanding our place in the world. We are not separate from this grand natural process. The weather that waters our crops, the rivers that provide our drinking water, and the oceans that regulate our climate are all part of this same powerful system. When we witness a storm or stand on a shore shaped by endless tides, we are looking at the very processes that have allowed life in all its wonderful diversity to flourish on this remarkable blue planet. It is a spectacle of immense power, and one that commands our deepest respect and curiosity. From the silent, cold expanse of space, our Earth offers a truly wondrous sight. It is not brown or green, but a swirl of brilliant blue, decorated with plumes of white cloud. This is because our world is, fundamentally, a planet of water. More than 70% of its surface is covered by vast interconnected oceans. This immense body of water is the lifeblood of our planet, the cradle where life first began, and the engine that drives our global climate. The oceans hold a staggering 97% of all the Earth's water, a reservoir so vast it is almost beyond our comprehension. This great blue expanse dictates our weather, absorbs vast quantities of carbon dioxide, and is home to the greatest diversity of life on Earth. The oceans are far from being a single uniform entity. They are a complex system of currents, temperatures, and depths constantly in motion. Great rivers of water like the Gulf Stream circulate around the globe, transporting heat from the equator towards the poles. This colossal circulation system acts like a global thermostat, moderating temperatures and making vast regions of our planet habitable. Without the oceans absorbing and redistributing the sun's energy, the equator would be unbearably hot, and the higher latitudes would be locked in a permanent, bitter chill. This movement of water is a quiet, continuous process, but its influence on life on land is absolutely profound. Beyond climate regulation, the oceans play another vital role through the rhythmic daily pulse of the tides. Twice each day, along coastlines all around the world, the sea level rises and falls in a predictable, mesmerizing rhythm. This is the tide, a bulge of water pulled across the Earth's surface by the gravitational forces of the Moon and, to a lesser extent, the Sun. This constant ebb and flow creates a unique and challenging environment in the intertidal zone, the area of land between the high and low water marks. Here, life must be incredibly resilient, adapted to being submerged in salt water one moment and exposed to the air and sun the next. This vast watery realm is the heart of our living world. It generates more than half of the oxygen we breathe, thanks to countless billions of tiny photosynthetic organisms known as phytoplankton. These microscopic life forms are the foundation of the entire marine food web, supporting everything from the smallest shrimp to the great whales. The health of our oceans, therefore, is directly linked to the health of the entire planet. They are not just a feature of our world. In many ways, they define it, governing its climate, shaping its lands, and nurturing its incredible tapestry of life. The edge of the sea is a place of perpetual motion, a frontier where the solid land meets the fluid ocean. This dynamic boundary is constantly being reshaped by two powerful forces, tides and waves. As we have seen, the tides are caused by the gravitational pull of the Moon and Sun. As the Earth rotates, different parts of the planet pass through the bulges of water created by this pull, causing the sea to rise and fall. This gravitational dance is what creates the high and low tides we see each day. When the Sun, Moon and Earth align during a new or full moon, their combined gravity creates exceptionally high and low tides, known as spring tides. When they are at right angles, their pulls partially cancel each other out, resulting in weaker neap tides. While tides are the slow, predictable breath of the ocean, waves are its more energetic and immediate voice. Most waves are created by the wind. As wind blows across the surface of the water, it transfers its energy to it, creating ripples that can grow into powerful swells. The size of a wave depends on the wind's speed, how long it blows for, and the distance of open water it travels over, known as the fetch. A gentle breeze might create small ripples, but a persistent gale blowing across a vast ocean can generate colossal waves that travel for thousands of miles. These waves carry enormous energy, which is finally and dramatically released when they reach the shore. The combined effect of tides and waves is a relentless sculpting force on our coastlines. Waves are agents of erosion. They crash against cliffs with incredible force, compressing air into cracks and fissures, and breaking off pieces of rock. They also act as a form of liquid sandpaper, hurling sand and pebbles against the shore, slowly grinding it away. This process can create dramatic features like sea arches, stacks and caves. But waves also build and create. They carry sand and sediment along the coast in a process called longshore drift, depositing it in sheltered areas to form beautiful sandy beaches, spits and barrier islands, constantly redrawing the map. The character of a coastline, whether it is a rugged rocky cliff or a gentle sandy beach, is therefore the result of a long and ongoing battle between the land and the sea. The type of rock, the power of the waves, and the range of the tides all play their part in determining its form. This is a world of constant dynamic change. A beach you walk on today may look subtly different tomorrow, its sand shifted by the night's tide and the day's waves. It is a powerful illustration of how water, through its ceaseless motion, actively and endlessly shapes the very ground beneath our feet. For millennia, the oceans have been a stabilizing force for our planet, absorbing energy and regulating the climate with a steady, reliable rhythm. However, in the geologically brief period since the Industrial Revolution, human activity has begun to fundamentally alter this ancient balance. The burning of fossil fuels, coal, oil, and gas, has released unprecedented amounts of carbon dioxide and other greenhouse gases into our atmosphere. These gases act like a blanket, trapping heat from the sun and causing the Earth's overall temperature to rise. A staggering 90% of this excess heat has been absorbed not by the land or the air, but by the vast expanse of our oceans. This absorption of heat is having profound and far-reaching consequences. As the oceans warm, the water itself expands, a process known as thermal expansion. This, combined with the melting of glaciers and ice sheets on land, is causing global sea levels to rise at an accelerating rate. For the hundreds of millions of people living in low-lying coastal communities around the world, this is not a distant threat, but an imminent reality. It means more frequent flooding, the contamination of freshwater sources with salt, and the slow but steady erosion of the land they call home. The very existence of some island nations is threatened by this inexorable rise of the sea. Furthermore, the excess carbon dioxide in the atmosphere is also being absorbed by the oceans, changing their very chemistry. When CO2 dissolves in seawater, it forms carbonic acid, making the water more acidic. This process, known as ocean acidification, is sometimes called the other carbon dioxide problem. It is a silent but devastating threat to marine life, particularly organisms with shells or skeletons made of calcium carbonate, such as corals, clams, and oysters. For them, living in more acidic water is like trying to build a house while someone is dissolving the bricks. Coral reefs, the vibrant rainforests of the sea, are especially vulnerable and are bleaching and dying at an alarming rate. The warming water also holds less dissolved oxygen, creating vast dead zones where most marine life cannot survive. It disrupts the migration patterns and life cycles of countless species, from tiny plankton to large fish stocks, which in turn affects the entire marine food web. The human fingerprint is now clearly visible on the oceans. We have inadvertently begun a dangerous global experiment, and the results are becoming increasingly clear. The once stable engine of our planet's climate is being pushed into a new, more volatile and unpredictable state, with serious implications for all life on Earth. Storms are one of nature's most dramatic expressions of power, and hurricanes are the undisputed kings of storms. These immense rotating systems, also known as typhoons or cyclones in other parts of the world, are born over warm tropical oceans. They are, in essence, colossal heat engines, drawing their incredible energy from the warm, moist air rising from the sea's surface. As the water temperature rises, more moisture evaporates into the atmosphere, providing more fuel for these storms to form and intensify. A sea surface temperature of at least 26.5 degrees Celsius is generally required for a hurricane to begin its life cycle. As our climate changes and the oceans get warmer, we are effectively adding more fuel to the fire. The scientific evidence is increasingly clear. While the total number of hurricanes may not necessarily be increasing, the ones that do form are becoming, on average, more powerful, more destructive, and more intense. They carry higher wind speeds and, because a warmer atmosphere can hold more moisture, they unleash far greater amounts of rainfall. This leads to catastrophic flooding, often far inland from where the storm first made landfall. The hurricane season is also becoming longer, with storms forming earlier in the spring and later in the autumn than they used to. The impact of these supercharged storms on coastal communities and ecosystems is devastating. The destructive power of a major hurricane comes from a trio of threats. First, there are the ferocious winds, which can easily flatten buildings, uproot ancient trees, and turn loose debris into deadly projectiles. Second is the torrential rainfall, which can cause widespread flash flooding and river overflows. Perhaps the most dangerous element, however, is the storm surge. This is a vast mound of water, pushed ahead of the storm by its powerful winds, which crashes ashore and inundates everything in its path. It is this wall of water that is responsible for the greatest loss of life and destruction during a hurricane. For wildlife, the impact is just as severe. A powerful storm surge can scour coastal habitats, destroying sand dunes, flattening mangrove forests, and pushing salt water deep into freshwater marshes, killing the vegetation that holds the ecosystem together. Coral reefs can be shattered by the immense power of the waves. Animal populations can be decimated, their nesting sites destroyed, and their food sources wiped out. In this warming world, the fierce face of water is becoming more common, and the gathering storms on the horizon pose an ever-increasing threat to both human and natural communities along our planet's coasts. The coastline is a place of relentless energy and constant change, a challenging environment where only the most adaptable can survive. Here, life must contend with pounding waves, shifting sands, and the daily rhythm of the tides, which can mean being submerged in salt water one moment and baked by the sun the next. Yet, despite these harsh conditions, a remarkable array of animals has evolved to not only survive but thrive in this dynamic world. Creatures like pelicans, gulls, and dolphins are masters of the coast, each having developed a unique set of skills and physical traits to make a living on this difficult frontier between land and sea. The pelican is a wonderful example of an animal perfectly suited to its environment. With its enormous throat pouch, long bill, and keen eyesight, it is a formidable hunter of fish. From high above the waves, it can spot a shoal of fish shimmering beneath the surface. It then performs a spectacular plunge dive, folding its wings back and hitting the water with incredible precision, scooping up fish and gallons of water in its pouch. After a successful dive, it tips its head forward to drain the water before swallowing its catch. This dramatic hunting method allows it to exploit the rich marine life found just offshore, making it a true icon of the coast. Gulls, often seen as ubiquitous and opportunistic, are another marvel of coastal adaptation. Their success lies in their sheer versatility. They are intelligent birds with a varied diet, capable of eating anything from fish and crabs to discarded human food. This flexibility allows them to find sustenance in almost any coastal setting. One of their most remarkable adaptations is their ability to drink seawater. They possess special glands located just above their eyes that work to excrete excess salt from their bloodstream. This salt is then expelled as a concentrated brine that drips from the tip of their beaks, a simple yet brilliant solution that allows them to stay hydrated far from any freshwater source. Meanwhile, just beyond the breaking waves, dolphins navigate the coastal waters with grace and intelligence. These highly social marine mammals have sleek, streamlined bodies that allow them to move through the water with minimal effort. They use a sophisticated form of sonar called echolocation to find fish and navigate even in murky water. By emitting a series of clicks and listening for the echoes, they can build a detailed mental picture of their surroundings. This ability, combined with their cooperative hunting strategies and complex social structures, makes them one of the most successful predators in the coastal ocean, true masters of their fluid world. The challenge of survival in the natural world has driven the evolution of some truly astonishing behaviors and strategies. In the competitive coastal environment, where food can be plentiful but difficult to catch, animals have developed ingenious ways to gain an edge. The brown pelican, for instance, often hunts not as an individual, but as a coordinated team. A group of pelicans will work together, flying low over the water and beating their wings to herd a shoal of fish into a tight, dense ball. They effectively create a living net, concentrating their prey in one small area before they begin their spectacular plunge dives, ensuring a greater chance of success for every member of the flock. This spirit of cooperation is a powerful survival tool. Gulls, too, demonstrate complex social behaviors that contribute to their success. They are highly communicative birds, using a wide range of calls and body postures to warn others of predators, signal the location of a food source, or defend their nesting territories. By nesting in dense, noisy colonies, often on inaccessible cliffs or islands, they gain safety in numbers. Any approaching predator, whether from the land, sea, or air, is quickly spotted and mobbed by a furious cloud of squawking gulls, a highly effective deterrent that protects their vulnerable eggs and chicks from harm. Dolphins exhibit some of the most sophisticated cooperative hunting techniques seen in the animal kingdom. In some parts of the world, coastal dolphins have developed a remarkable strategy known as mud netting. One dolphin will swim in a decreasing circle around a shoal of fish in shallow water, beating its tail fin against the muddy seabed. This action stirs up a plume of mud that forms a temporary circular net, trapping the panicked fish inside. The fish, seeing the wall of mud, will leap out of the water to escape, often straight into the waiting mouths of the other dolphins in the pod. This is not instinct, it is a learned behavior, passed down from mother to calf, a true sign of animal culture. These examples are a testament to the incredible ingenuity that evolution can produce. They show that survival is not just about being the strongest or the fastest. It is also about being clever, adaptable, and in many cases, learning to work together. From the pelican's team fishing to the dolphin's muddy trap, the animal kingdom provides countless examples of complex problem-solving. It demonstrates a deep and intricate understanding of their environment, a form of natural wisdom that has been honed over millions of years of trial and error, resulting in the beautiful and effective survival strategies we can witness today. As we have seen, the natural world, particularly where the water meets the land, is a place of immense power and perpetual change. It is shaped by forces that can appear violent and destructive, yet from this seeming chaos arises a world of incredible resilience and adaptation. The animals that make their home on the coast do not just endure the harsh conditions, they have evolved to become part of the rhythm of the ocean itself. The gull that drinks the salt sea, the pelican that harnesses the power of the group, and the dolphin that paints a net with mud, all show us that life has an incredible capacity to find solutions and to thrive in the face of challenges. This inherent resilience of nature offers us a profound and timely lesson. We now live in an era where human actions are accelerating change on a global scale, making our weather more extreme and our oceans more volatile. We are facing challenges of our own making, from rising sea levels to more powerful storms. It can be easy to feel overwhelmed by the scale of these problems, but the natural world shows us that adaptation is always possible. Life has always found a way. For billions of years, it has responded to changing climates, shifting continents, and catastrophic events, diversifying and persisting through it all. Our own survival and prosperity depend on our ability to learn from this. We must become as adaptable and innovative as the life we see around us. This means understanding the natural forces at play and working with them, not against them. It means protecting the ecosystems like mangrove forests and coral reefs that provide natural defenses against storms. It means developing new technologies and ways of living that reduce our impact on the planet's climate system. Just as the gull evolved a gland to deal with salt, we must use our own unique adaptation, our intelligence and foresight, to navigate the changes we have set in motion. The power of water will continue to shape our world as it always has. It is a force that demands our respect, not our fear. By observing the intricate and ingenious ways that life adapts to this power, we can find inspiration. We can see that resilience is not about resisting change, but about adapting to it. The future of our own species on this beautiful blue planet depends on our willingness to heed this fundamental lesson from nature. If we listen, and if we learn, we too can find a way to thrive in the changing world we inhabit, ensuring a healthy and stable future for generations to come.